Hi guys, I'm sorry I'm going to miss you today. I'm at a training all day, but I want you to watch this video, follow along, and if you have any questions, you can ask Ms. Stagg. So here's our agenda for today. Take note of the homework, which is going to be a quiz review, and some upcoming dates. Keep in mind your quiz on functions is the next time that I see you. Your unit test, I decided on a definite date. That's going to be cycle 6, meeting 2. All right, let's get started. Here are homework answers to last night's homework, so take a minute, check those. If you have trouble with that, I posted a homework tutorial video as well, so you can always check that video. So you can pause and check answers. All right, guys, so if you're good with the homework, then you'll need your toolkits today, and you also need some paper to jot down some things. And then at a certain point, you'll need a handout, but I'll kind of tell you more about that when we get there. All right, so let's get started. First, let's go through a definition. Here's a definition that you need to know. So put this down in your toolkits, okay? So function notation. This you saw a little bit in the homework last night. So function notation indicates that you are referring to a function that you're referring to a function and names that function. So for example, this is function notation. F of x equals, or g of x equals, or h of x equals. And when you read it, notice I wrote that it's read f of x or g of x. So a lot of times you'll write functions, you'll see equations that'll say like f of x equals 2x plus 7. That just means that let's call this function 2x plus 7, let's call that function f. And then if we have like g of x is equal to 3x, let's call this 3x, let's call that function g, okay? So basically f of x, g of x, this function notation is no different than saying y is equal to 2x plus 7 or y is equal to 3x. Function notation allows us to differentiate between like this y and this y. It kind of gives us a name. Okay. Something else I want to show you down here at the bottom, this section down here. F of 2, so let me erase all this stuff. F of 2 equals 7. That means that 2 was the input and 7 was the corresponding output of the function f. Okay, so for example, let's say that my function is f of x is equal to 3x plus 1, okay? If my function is f of x equals 3x plus 1, and I were to say to you, well, evaluate when x equals 2. So x is the input. We've talked a lot about inputs and outputs. So you're plugging in 2 for x, and what's going to happen? You simplify and you get 6 plus 1, which is 7, right? So in other words, we have like f of x equals 7. So 7 is my output, correct? Another way of writing this, instead of writing f of x, I can write f of 2 is equal to 7. And that's just kind of shorthand notation telling you that when 2 was your input, 7 was your output. Okay? Make sense? All right. So a couple more problems from the book. So I've copied them here, but you can also take a look at them in your book if you'd like to. 1-5-6. Examine the function to find it right. So a function can be in the form of a graph. It doesn't have to be an equation, all right? So we have this function. Notice that g of 1 is equal to -1. That is, when x equals 1, the output is -1. So here's x equals 1. Here's the x-axis, and y-axis, right? X equals 1 is right here. That's where x equals 1. Well, if I look here at my graph, where does x equal 1 on this U shape? Right down there. Do you see where I put that point there? Right down here is where x equals 1. What is the value of y at that point? Y is equal to -1. So therefore, I can say that g of 1 was my x value, it was equal to -1. Okay? So let's go through some of this. What's the output of the function when the input is 2? Okay? So when the input, or in other words, x equals 2, that's right here, right? So what's the output? What's the y value? That should be 0. So therefore, g of 2 is equal to 0, okay? So now let's find g of -1 and g of 0. So g of -1, when g is negative, or I'm sorry, when x is -1, let me go up here, that's that point right here. My y value is 3. And when, I'll finish this one down here, when x is 0, my y value is also 0, okay? So these were my answers to letter B. Letter C, what is the input of this function when the output is 1? So let's look at the output now. Those are the y values. So here's kind of where y is 1. Well, that happens here and here. So in other words, find x when g of x equals 1. Is there more than one possible solution? Yeah, there's actually 2 possible solutions, like we just said. Here at this point and here at this point, right? I can't tell exactly what these are. They look to be like maybe 2.3 and maybe -0.5 or so. But my x values, I'm going to say my x values are approximately, let me erase this so we can get a better look. My x values are approximately, let's say 2.3 and right here, looks like maybe -0.4. It looks like a little less than a half, okay? So that's part C. All right, those are a little tricky. 1-57 is a little bit more straightforward, okay? If this is my function, okay, f of x is equal to x squared. This is telling me right here that x is 4. When x is 4, I plug in and I square 4 and I get 16. So find these 3 values. So take a minute, find these 3 values. So you're just plugging in. So f of 1, you would plug in 1 for x squared. So that means 1 squared. 1 squared is 1, right? All right, take a minute, try those 3 problems. You can pause the video. And now that you've finished those 3 problems, here's some answers. So that was A. B should be f of -3 should be equal to 9. And C, f of t should be equal to t squared. Okay? All right, guys, let's look at another couple problems. So 1-62 in the book, the cola machine. So you have a soda machine. You guys know how a soda machine works. Part A, it says describe the input and output. What do you put into the soda machine? Money, right? You put money in, and what do you want to get out? You want to get out a soda or water, whatever it might be, right? When you press a button on that soda machine, you expect, if you press the button for Diet Coke, you expect to get a Diet Coke out. If you press the button for Diet Coke and you get a water out, are you going to be happy? No. So take a minute, pause the video, and answer these couple questions. All right, so now that you've answered those couple questions, let's take a look at these 2, okay? So 1-63, in a relationship like the soda machine, we want the outcome to be consistent and predictable. We want the machine to function properly. So let's look. Here's some inputs and here's some outputs. This is letter I, okay? Or letter number 1, sorry. So if button number 1 gives me sticks, should button number 1, I'm kind of repeating myself, also give me sticks? Yeah. If I hit button number 2, it gives me M&Ns. But over here, look over here. I have, so here's button number 2 giving me M&Ns, and here's button number 2 giving me duds. So that means like sometimes when I hit 2, I'm going to get M&Ns, and sometimes I'm going to get duds. Does that make me happy? Probably not. So is this functioning properly? Probably not. Let's look at number 2. Here, think of this the same way. So now I'm going to press button number 7. Instead of getting a candy or soda, I'm going to get a number. When I press button 7, I get a 6. When I press button -2, I get a -3. When I press button 0, I get a 4. And so on and so forth, right? Does it look like each time I press a different button? So press a different button. Does it look like I get consistent and predictable outputs? It looks to me like that one's working. But let's look at number 3, okay? So when I press the button, am I getting consistent and predictable outputs? Let's look, okay? So what pops out to me is when I press button 2, sometimes I get a number 9 and sometimes I get a -8. That's no good, right? That means that is not, that soda machine or number machine, let's call it, is not functioning properly. All right, if you want to kind of check your answers for some of the problems we just did, you can pause the video and look here. Moving on, let's formalize this definition of a function. So pause the video and write all this down in your toolkit, please. And then we're going to talk about each of these things. All right, guys. So now that you've written that down, you need to get this sheet from Miss Stagg. It says, is it a function practice? Looks just like this. So make sure you get that sheet. And then let's go through some of these. Keeping in mind, if I have some data in a table, it's a function if it's functioning properly like that soda machine, if each input has exactly one output, okay? And I wrote down in the toolkit in red before, you know, a good way to kind of check that is you should never have like a button being repeated. So if I look at example A, this function machine, you can think of it, is not functioning properly because when I press button 4, I have 2 different outputs. So it says determine if the data is a function, explain why or why not. It's not, because an input of 4 gives 2 different outputs. Make sense? All right, let's look at letter B. In this case, my inputs are 3, 5, 7, 9. My inputs or my x values are not being repeated. Therefore, yeah, I'm good. I know that this is a function. Every time I press the button, it's going to give me one unique output. All right, now let's relate this to x and y. If we look at letter C, my inputs are 1, 3, 5, 7. Are they being repeated? No. So yes, it is a function. Okay. Take a minute, pause the video, and try the rest of these, and then I'll give you answers. All right, guys, here's answers to those couple problems. So take a look. I did not explain. I'm expecting that you have explained on your paper. All right? Okay, moving on. So now if I have a set of points, let's determine if it's a function or not, okay? Again, my x value shouldn't be repeating. Keep in mind, points are listed, x comma y. X is my input, or in other words, the button I push. Y is my output, or in other words, the soda that comes out of the machine, okay? Here in this one, my x is being repeated 3 times. So this is not a function, okay? And that's because my x value of 4 has 3 different outputs. All right, letter H. My x values are 0, 1, 3, and 2. None of them repeat, so therefore it is a function. All right, pause the video, try the rest, and then you can resume. All right, guys, so there's some answers to those couple. So take a look at those. Again, I didn't explain, but I'm expecting that you explained that, like for letter I and J, none of the inputs are being repeated. But for letter K, when I have an input of 3, sometimes I get a 3 as an output, and sometimes I get a -1. That's no good. All right, last thing that I promised we'd talk about is called the vertical line test. So if you're given a graph, and you need to determine if it's a function or not, you can use what's called the vertical line. A vertical line goes up and down, right? This is a vertical line. This is horizontal, okay? we are doing the vertical line test, so we don't care about horizontal lines here, all right? So what you're going to do is you're going to draw vertical lines on your graphs, okay? And anytime that you draw a vertical line, it should only pass through a point, one point on the graph, okay? So I'm going to write down what the vertical line test says, and if you want, you can copy it down as. Okay. Okay, so there's what the vertical line test says. A vertical line should only pass through one point on a graph. So if I'm going to start with letter L, I'm going to draw vertical lines. Here it only passes through one point.
-10. So is this?
Okay, so if I draw another vertical line through here, it only passes through one point. We're good, it's a function. If I draw a vertical line here, 1 point. Here, 1 point. Here, 1 point. Here, 1 point. So each vertical line only passes through 1 point. So yes, letter L is a function. So take a look at M. Anytime I draw my vertical lines, they only pass through 1 point. So those are functions, okay? Take a look at N. 1 point, 1 point, 1 point. But look, what happens here? We have 2 points. So this passes through 2 points, so therefore it's not a function. And your reason, and you would write this down, is because my vertical line that I draw passed through 2 points. All right, now let's look at letter O. Look at this vertical line. It passes through the graph in 2 different places. So does this one, passes through in 2 different places. So this is not a function, all right? Letter P, if I draw my vertical lines, each of these is only passing through at 1 point. I could keep going and going and going, but they're only going to pass through 1 point. So yes, that is a function. Q, I'm going to draw all my vertical lines, and they're only passing through at 1 point at a time. So yes, Q is a function. So try these last couple, and then I'll give you answers in just a second. All right, guys, check these last couple answers. You can pause the video if you need to. All right, if you still have more time before the end of the period, you can take a minute and please log on to my Algebra 1 Khan Academy page. So follow these directions, and if you get a chance, you can complete the pre-algebra mission. So go up in the right-hand corner to where your account name, where your logon name, once you're logged in and everything, and you'll see pre-algebra mission. If you don't have time to get to this today, no big deal. Thanks for watching. If you need to, go back and rewind, rewatch, and keep in mind, this is your homework coming up. Quiz review is due tomorrow, and you have your quiz tomorrow and your test coming up. Thanks. Have a great day.